morning, everyone. This is our fourth training. It is about Wflow hydrologic model. We are going to talk about different gridded inputs. So we will start with the static map. We have as an input to our Wflow model, we have different types of gridded inputs. The first one is the static map, and here, for example, we have the elevation map and land use map. And the second type of maps, these are derived parameters maps. And here, for example, this is like the depth of vegetation roots. This is a derived parameters map. We also have dynamic map. These are the maps which are changing, and the example for these maps, this is the precipitation and temperature map. So we have three types. We have the static map, the derived map, and the dynamic maps as an input to our model. We also have gridded outputs, and here these are like the dynamic maps and location time series. This is the gridded output, and we talked about our fully distributed model. For our fully distributed model, the results are produced at each grid of the model. So here we can extract like our time series at any specific point. So this is like the dynamic maps, location time series. We can define different locations to extract the result and to extract like the time series. We're going to see that later. So this is our discharge. For example, here we can extract it. The unit for it is meter cube per second. We can also extract like water levels, which is in millimeter. So as we said, we have static maps. For example, like the average evapotranspiration and the total rainfall interception by vegetation. So these are like the different gridded outputs. We have dynamic maps and local time series. We also have some static maps as gridded output. We also have for the Wflow schematization, the inputs in general. We say these are like static input maps. We need here, for example, the digital elevation model, the DEM. We need also like some other hydrological parameters like the flow directions. We need information about rivers. We need information about land use map related to the parameters. We also need soil maps, and we need, if it is available, lakes and reservoirs. For our case here, it is not available. If glacier is there, we can also need some kind of locations and characteristic, but we don't have glaciers here. So this is just an example of the DEM and the land use map. These are like the subcatchments, and these are our rivers. We also have dynamic input data like the precipitation, for example, the potential evapotranspiration, and also the temperature. We have parameters in the Wflow model, and they are given in a map file. This is the static map file. We managed to use Panoply to open this static map and to plot these different static maps, and to see the units, to see the variation of these different maps. We also derived from land use, soil, and rivers. We also have other kind of maps here, like for example, this is saturated hydraulic conductivity. We can also open this kind of map. We have porosity. This is also another type of map. We manage also to open these maps. And for our Wflow, we have vertical parameters, but on the same time, we have horizontal parameters. This is an example, for example, of vertical parameters like threshold temperature interval. We also have, for example, soil temperature, smooth factor, and we have the unit, we have the default and description and the name of the parameter. So these are all parameters which are available in Wflow, for example, like the saturated water content or the porosity, what is the unit, and also here what is the default value. We have the vertical hydraulic conductivity at soil surface. We have the soil thickness. For example, here, if it is 2000 millimeter, which means it is like 2 meter. We have the infiltration capacity, compacted area, the soil infiltration capacity. We have the maximum leakage from saturated zone. And these are like different kind of vertical parameters, like the rooting depth. For example, it is here 75 centimeter or 750 millimeter. These are different vertical parameters at Wflow, like the crop coefficient, also the KC, the maximum canopy storage. These are still different parameters you can explore, and you can know the unit, the default value for these different parameters. We have also what we call the lateral parameters for the Wflow. For example, these are different lateral parameters. For example, the discharge, the length, like meter cube per second here, for example. All these are horizontal parameters. For example, the abstraction. We have the kinematic wave, volume. We have water level. Of course, it's in meter. Average water level, bank for river depth. The model time step, this is the dt, it's in second, for example. So these are different horizontal parameters. So this is briefly our fourth training. Thank you very much.